y'all hear me?
Yes, ma'am.
Okay. I can't see any of y'all. Can y'all see this sheet with my hand on it?
Yes, ma'am.
Okay. So I don't know what's different about my settings here, but if y'all need to ask a question, just interrupt me and ask a question. First of all, everybody needs this piece of paper. It says important trig identities and formulas. Does everybody have that out? Are we ready?
Yes, ma'am.
Okay. Chapter 3 of Trig deals more with these rules or these identities than it does really with trig problems or triangles like y'all are used to seeing. So I'm going to start, and this is what the book looks like. If you go in your My Math Lab program, you have access to a digital textbook, and I'm just going to kind of walk through it and talk about some problems and show you some things. In your digital textbook, and also I sent y'all a PDF file of some of these pages and some things you'll find in there. These identities, these are the same identities that are on that sheet, and they're grouped by name. There's some reciprocal identities, which means that sine is 1 over cosecant, cosine's 1 over secant, tangent's 1 over cotangent, cotangent's 1 over tangent, and so on. There's some quotient identities, which tells you that tangent is really sine over cosine, and cotangent would be the reciprocal of that. There's Pythagorean identities and even odd identities. We won't really talk about those today. They're also listed like that on this sheet, but on this sheet you have a whole lot more. Some of the problems that you see in this section, now we'll say, verify the identity that secant x times cotangent x is equal to cosecant x. And that'll be the problem. And what you'll need to do is you'll need to try to write the more complicated side in terms of sine and cosine. The very first skill that you have, or the very first thing that you should try, is to write things in terms of sine and cosine, and then usually things will simplify. So I'm going to go to this sheet, and I'm going to go to the reciprocal identities, and I'm looking for secant. And what does it say about secant? Oh, it says secant is 1 over cosine. So I'm going to write it right here. And now I'm looking for cotangent. And there's cotangent. It's 1 over tangent. Well, that's okay, but I really want it to be sine and cosine. So do I have some quotient identities? There's one right there. Cotangent is really cosine over sine. So I'm going to use that one. Now when I multiply these, I use the rules applied in fractions, and these cancel out, and this side is now 1 over sine x. Well, I want it to say cosecant x, so I go back to my reciprocal sheet, and sine is 1 over cosecant, and cosecant is 1 over sine, so it tells me there that those are equal, so I can write that as cosecant x, and I have verified the identity. Okay? That's example 1. Do y'all have any questions about how to do that? Are you with me? Are you together? Are you with me?
Yes, ma'am.
Okay. I'm going to go on to the next example. The next example says, sine x, tangent x, plus cosine x equals secant x. And they want you to prove that. Well, we're going to do the same thing. We're going to write everything in terms of sine and cosine. This is already sine, so I'll leave it alone. Tangent, I'll go to my sheet. Tangent is sine over cosine. And then I have cosine x. Well, I'm going to multiply this together because I don't really have anything else I can do, and that's going to give me sine squared x over cosine x plus cosine x, okay? Well, I've been doing this for a long time, and I kind of see this, and I kind of go over here to these Pythagorean identities, and I think, you know, it's kind of close to that. It's not exactly, but it's getting kind of close to that. So I'm going to do another fraction technique, and I'm going to get a common denominator. This really has a denominator of 1. So the common denominator for these two fractions is cosine x. The first one doesn't change. To get this one to say cosine x, I'm going to have to multiply the bottom and the top by cosine x. So it gives me this in the top. Then I can add them together because they have the same denominator. And I get sine squared x plus cosine squared x over cosine. Well, I go to my Pythagorean identities, and I see that sine squared x plus cosine squared x is really 1. So this numerator is really 1. So now this is 1 over cosine x. And I'm trying to get it to be secant. And it tells me here that 1 over cosine is the secant. So this is really the secant of x. So I have proved that, or I have verified that sine x times tangent x plus cosine x is really equal to the secant x. Now I know this is different than anything you've ever seen or done before. Okay, so you may want to stop this video. You may want to read it. You may want to look at the video again. I'm trying to record it, so maybe I can post it to YouTube or something. You may want to take your phone out and take a picture of this as we move through it. If you get stuck and you want me to, or maybe you want me to take pictures on my phone of these examples and then upload them or email them to you, just so you'll have something to go by, because these are different. I realize they're different, but they're all, once you get in the hang of it, they're all fairly the same structure. Okay, next example. Everybody still hearing me okay and seeing me okay?
Yes, ma'am.
Cosine x minus cosine x sine squared x equals cosine cubed x. You're verifying that the left side equals the right side. So we're going to start to work on the left side. And I look at those two items and I see that they have something in common, and I'm going to factor it out. Much like you would do if you had 2x plus 4. You would take a 2 out and you would be left with x plus 2. Okay, we're going to use the same technique here. Both of these have a cosine. So I'm going to take cosine x out, and this one now is a 1, and this one is sine squared x. Okay, well, I'm going to my Pythagorean identities, and I see that sine squared plus cosine squared equals 1. Well, is there another way I could write that particular identity? Is there something else I could write that as? Can I rearrange it? So I'm going to rearrange it here. It says sine squared x plus cosine squared x equals 1. Well, I'm going to subtract sine squared x from each side just to see what happens, because I want to try to make it say 1 minus sine squared x. And I get cosine squared x equals 1 minus sine squared x. Okay, these two things are equal. Okay, this is that same Pythagorean identity from right here. It's just written in a different way. And it's useful to me in this particular problem. You could have subtracted the cosine from both sides and had that same identity written in a third way. But for this problem, this is what I need. I need to replace 1 minus sine squared with the cosine squared. So this now says cosine x times cosine squared x. And when I multiply those together, I get cosine cubed x, which is exactly what I'm looking for. Okay? Questions on that example? How are we doing? We doing okay? Can you still hear me?
Yes, ma'am.
Okay. All right. Well, I'm going to move on. I'm going to do another one. The next one says 1 plus sine theta over cosine theta. We're trying to prove it's equal to the secant of theta plus the tangent of theta. Well, in a previous problem, I got a common denominator and I put things together and made a fraction. In this problem, I'm going to show you how you can pull them back apart. So this was really 1 over cosine theta plus sine theta over cosine theta. See, I can undo that fraction work like I did earlier. Then I can try with 1 over cosine. There's 1 over cosine. It's equal to secant. So this is secant theta. X and theta are, you just use whatever you want. There's no difference in X or theta or Y or whatever on there. And then sine over cosine is the tangent. So that's adding the tangent of theta. So there I have verified that identity. Any questions so far? Okay, I'm going to move on. The next one's kind of long. All right. The next problem says cosine x over 1 plus sine x plus 1 plus sine x over cosine x, and they want to prove that it's equal to 2 secant x. Okay, well, as I look at this problem, I see fractions. Everything's already in sine and cosine on the left. So all that I know to do is to try to get a common denominator. And the common denominator, this is one of those times where you have like 3 over 5 plus 2 over 7. The only common denominator you're going to get for that is 35. You just multiply the two things together. So the common denominator is 1 plus sine x times cosine x. So I've got to transform that fraction into that and this fraction. The first fraction already had 1 plus sine x in the bottom. So what I really needed to do here was multiply by cosine in the top and the bottom, and it's going to give me cosine squared x. The second fraction had a cosine in the bottom, so all it needed was to be multiplied by 1 plus sine x. Okay? So that's going to be squared right there. Now, I'm going to write this over one fraction, 1 plus sine x times cosine x. I have cosine squared. Now I'm going to have to FOIL this out. I'm going to go over to this little piece of paper and I'm going to do the FOIL on this other sheet. 1 plus sine x times 1 plus sine x. You just treat it just like you would anything else when you FOIL. 1 times 1 is 1. 1 times sine x is sine x. Sine x times 1 is sine x. And then the last one is sine squared x. And y'all know when you put the middle terms together, it's 1 plus 2 sine x plus sine squared x. So that's going right here beside this. 1 plus 2 sine x plus sine squared x. Well, at this point, I identify sine squared and cosine squared, and I go back to my Pythagorean sheet, and it says if you're adding those two together, it's really equal to 1. So that and that really are 1. So I'm going to replace them with a 1, and I still have this 1, and I have 2 sine x over 1 plus sine x times cosine x. Well, I'm going to clean the top up, and it becomes 2 plus 2 sine x over 1 plus sine x times cosine x. Looking at the top, it doesn't look, I'm trying to get to 2 secant. It doesn't look like it yet. But I noticed that in the top I have 2 that I could take out. I'm going to factor out a 2, and it's going to be left with 1 plus sine x. The denominator is 1 plus sine x times cosine x. Now I can cancel those because I have the same thing in the top and the bottom. Now I'm getting somewhere now. It's 2 over cosine x. Well, that's like having 2 times 1 over cosine x. And cosine x, 1 over cosine x is the secant. So I finally got it to say 2 secant x. Now this one was long and this one was complicated. So you may have to go back through this thing and listen to it 2 or 3 times. You may have to keep practicing it. But don't give up. If you know, you can do it. I know you can. So far, do y'all have any questions?
No, ma'am.
No? Okay. That's as far as I got with my kids the first day when I talked with them about it. And then I wanted them to kind of start. I mean, I could go on and work more problems, but until you've practiced this a little bit, the rest of what I have to show you won't make good sense. So if you don't have any questions, what I think we need to do is y'all need to work on your homework. And if we need to Zoom again this week, all you got to do is email me. I don't know of any reason that I can't Zoom every day or every other day. But I want y'all to get started on the first section. Just do some problems and getting started, but also do some problems in 3.1 because I want you to get used to how they're asking you to work them. It's a little bit different than anything else you've done, but write down questions you have and get back with me and let me help you answer those. How does that sound for y'all?
I have a question on getting started. I forgot how to factor with the number in front of the x squared.
Okay, so you're going to call the problem out to me because I don't have any way of seeing it. So call it out. Let me work it for you.
Okay. Hang on, let me pull it up. Okay, it's 5x squared minus 34x minus 7.
Okay. So when you start to factor here, you have to break it down into two parentheses, and this is 5x and this is x. And then the choices for the 7 are 1 and -7 or -1 and 7. And you kind of play around with that to see what works out. If you place the 7 here, it gets multiplied by the 5 and it makes a 35. And we probably need it because it's a 34 in the middle. If you place the 1 here, 1 times 5 is 5, and then you'd have the 7 here, and that'd be 7 and 5, and that'd be 12, and that's not close enough. So I'm going to put the 7 here. And the 34 is negative, so I'm probably going to want the 35 to be negative. And then that gives me a +1 in the middle. Now I'm going to check that work. That's going to give me 5x squared minus 35x plus 1x minus 7. So in the middle, I get the -34 that I need. Now, if they're asking you just to factor, then you're done at this point. But if they're asking you to actually solve, you take 5x plus 1 and set it equal to 0, and x minus 7 and set it equal to 0, and finish out your algebra with -1/5, and then x is 7. Did that help?
Yes, ma'am.
Do y'all have other questions?
Would you do the same thing with 7x squared minus 2x?
Okay. If you only have 2 terms, then you're probably not going to do backwards FOIL, but you look for what they have in common, and these both have an x in common. So you can take an x out, and you're left with 7x minus 2. And that's all you can do there. If they want you to make it equal 0, you get x equals 0 or 2 7s.
Okay.
Next question.
That's all the questions I have.
Okay, anybody else? No? Okay, well, I'm going to end this session. I'm going to try to record the video and get it to you some way. I'll send you an email about that. But y'all work hard and let me know if you have questions. And I don't mind one bit helping you out tomorrow, the next day, whatever it takes, okay? All right, we're going to end it now.